Hi friends, welcome to another lesson. We thank God for the opportunity to learn. Grade 11s, grade 12s, we are drawing another graph. Like I always say, look at the equation, try to identify the graph first. What graph are we dealing with? Okay, it looks like this graph has a form y equals a over x minus p plus q. And that's a hyperbola. Well done. You got it right. It's a hyperbola. Now, try to get the general shape of a hyperbola. Normally, when we draw a hyperbola, we're going to have an asymptote, vertical one, the one that cuts x. Then we're going to have horizontal one. And then we're going to have a curve and another curve on the opposite quadrant. Normally, we're going to have something like that. So what do we need? We need to know our horizontal asymptote, where it's cutting y, and our vertical asymptote, where it's cutting x. We need to know the y-intercept, if there's any. We need to know the x-intercept. So it's four things. Let's know them as a guideline. So we need horizontal asymptote, Number two, we need vertical asymptote, asymptote. Three, we need the x-intercept. And then we need the y-intercept. If we can get those, we should be able to draw the graph comfortably. Okay? So let's do the calculations. Let's find the points. Nice. Okay, let me go on. Oops. I want to erase here. That was just a sketch so that we see what we need. Okay, it was just a guideline. Beautiful. Let's start with the asymptotes. So, from the standard equation, this will give you your vertical asymptote. That will give you the horizontal asymptote. Okay, those two will give you the asymptotes. So now let's look at the given equation. You can see that P is 4 and then Q is 6. So we are just going to extract them as they are. You see here it's x minus 4. That means if there's a minus here, when you go on and write your vertical asymptote, you're going to say positive. If it was plus, you're going to say it's minus 4. Okay. Let's go ahead and start with the horizontal asymptote. It's going to be Q equals to 6. So that always gives you the horizontal asymptote. Then let's go on and find the vertical asymptote. Remember I said when you check here, if it's minus 4, you know your vertical asymptote is going to be positive 4. If it was plus, it's going to be minus. It always opposes. So P equals to positive 4. Beautiful. Now we need to work out the x-intercept. The x-intercept and y-intercept, the concept doesn't change. For x-intercept, you let y be 0 for any graph. So x-inter, we're going to let y be 0. Beautiful. Let's go on and let y be 0. We have 0 equals to 12 over x minus 4 plus 6. Okay? Need some space. Then we're going to solve for x. What you want to do, transpose the 6. Take the 6 to the other side of the equal sign first. You're going to have minus 6 equals to 12 over x minus 4. Then what you want to do now is to cross this x minus 4, cross multiply. Multiply the numerator on the other side of the equal sign. So you're going to have minus 6 into x minus 4 equals to 12. Great. Now multiply. Minus 6 multiplied by x is going to be minus 6x. Minus 6 multiplied by minus 4 is going to be plus 24 equals to 12. Transpose the 24. It's going to be minus 6x equals to 12 minus 24. So you're going to have minus 6x equals to minus 12. Divide both sides by the minus 6 so we can be left with x. Then we get x to be 2. Beautiful. Let's go on and find the y-intercept. So for the y-inter, we're going to say let x equals to 0. If you want to find y-intercept for any graph, you must let x be 0. Let's go ahead. Let x be 0. So it means here we have 0. Y equals to 12 over 0 minus 4 plus 6. Okay, we need more space. Y equals to 12 over 0 minus 4 is minus 4 plus 6. You can just key this into your calculator and get the answer. 12 divided by negative 4 is going to be negative 3 plus 6. And the final answer is going to be 3. So, let's check what we have. We have an asymptote, the horizontal one at 6, vertical one at 4, the graph cutting x at 2, and intercepting y at 3. Let's go and mark those points on the Cartesian plane. Let me change the color. Green. Fine. Start with your asymptote. It makes things very easy. So horizontal, it's 6. I'll just go ahead and put 6 there. And then this is how we plot the asymptote. We use a dotted line. Okay, that's a restriction. Okay, we never touch that line as we plot the graph. Now let's go ahead and plot the vertical asymptote. Vertical is the one that cuts x. It's cutting x at 4. Remember there? Right, so we have our asymptotes. Those dotted lines are restrictions. The graph or the curves must never touch. All right, let's mark the x-intercept. So if that's 4, x-intercept can be somewhere there, 2. And then if that's 6, y-intercept can be somewhere there, 3. So we have 2 and we have 3. We are going to draw a curve that's going to go through the intercepts and approach the asymptotes as far as you can go without touching the asymptotes. All right. Okay, it's supposed to approach the asymptote like that, but never touch those asymptotes. You approach them as far as you can. Then, on the opposite quadrant, see here we have the first quadrant of the asymptotes, second, third, and fourth. So you are going to draw another curve on the opposite quadrant. So this is the opposite quadrant. You are going to draw another curve that is a mirror image of the first one. Okay, like that. So if our first curve was at quadrant 2, it means the other one was going to be at 4, sorry. You must have the curves on opposite quadrant. They must always face each other, like that, or like that. Okay, they must always face each other. They must be opposite to each other, forming a mirror image along the line y equals to x. And that's how you draw this type of graph, the hyperbola. If you have any question, feel free to ask. We are going to assist you accordingly. Thank you very much, guys. I'll see you in the next lesson. I can say no over. Amen.